So as ladies and gentlemen, as a conclusion, I would say that the high speed is very important to be able to procure the block and to have full control of the device into the bone. Um, the high speed, even at 1250, which is the maximum limit of this machine, is probably sufficient, but I'm not sure. I would prefer to speed it up to about 2000 RPM, and that I think is not available in orthopedic units, but I'm not sure. And besides, we want a dedicated motor unit that can work the device superfluously. And so the speed itself actually doesn't cause much damage to the tissues, because most of the time the revolutions don't actually contact the patient. There's only a light touch when we're actually pushing the device downwards persuasively, and we're flushing it with coolants, icy cold saline, constantly, and that will offset the friction heat which is created during the revolutions. And so it's imperative to have icy cold water coolants. We use sterile saline, and typically on this machine we do have a bag of saline connected to a motor pump, which is here. Okay, we have a motor pump here. Okay, if you can see it. All right, and then it's connected by a tubing into the handpiece, which we have the sterile handpiece. And if I can find it, yes, this is a sterile handpiece, and then you see the tubing actually goes in through there from here, okay, and then that will pump the water spray directly onto the specimen. So anyway, this is actually a Straumann handpiece, okay, right. The point being that at high speed and offset by the coolants and with intermittent touching of the perimeter where we're actually going in, and subsequently the undercut, okay, at such a high speed there should be no tissue damage if it's well controlled, and there'll be no tearing, there will be no excessive cutting, and there will be no therefore excessive bleeding or trauma or possibility of damaging the surrounding tissues within the donor site. We're aiming for the pelvis, which is typical, the pelvic bone, but also we can consider to obtain the specimen from the sacral bone, okay, the sacrum, which is at the lower end of the spine. It's quite a wide and flat structure. All we need is about a 14 millimeter disc diameter by approximately 5 millimeter depth or length, approximately 5, maybe 8 millimeter, sometimes 10, depending on the degenerated area of the spine, and subsequently the void, the spinal space that we need to fill in. It's a circular structure, so the spinal column is actually circular. 14, maybe even 16 millimeter, I would approximate. And so if we can, our device is already at 12 millimeter diameter, and the length allowable is down to 22 millimeter, so we're nearly there. We need to fabricate a device which is approximately 14 or 16, so we'll have to find out the details of the dimensions that are relevant for the course. And so it's imperative that we actually have full control, and we can actually consider the length, which can be selectable. So therefore we have a motor unit which have a trigger, and then at any time during, the operator can select to trigger the to trip the trigger, and that will activate the base cut and undercut to limit the length of the block for extraction. The cutoff point. So we have a selectable cutoff point. It could be any time down at 5 millimeter or 8 millimeter or 10 millimeter. Then we trigger the lever, and that will lift the actuation ring, and that will instantly activate the micro saws at the base, and which will subsequently and quickly at 2000 RPM sever or section the length, at that length, the length of the bone disc that we require. And so it would be a selectable unit with a trigger. That is optional. We'll talk to the engineers about that. But the most important thing is a high speed, plenty of water coolant, intermittent pressure, and therefore we do not want to overheat the tissues. And then we can select the cut at any time, and as you know, it doesn't slip with a high speed, and the sharpness is actually sufficient. It's rather sufficient already. We could top that up. We could slicken the device, and we can make it more user-friendly in that manner, and ease of control. And the three things that are most important about this methodology is simplicity, conservation, is conservative, and we have a predictability. And there is no possibility of, or there's little possibility of damaging surrounding tissues beyond what it has been bargained for what has been agreed to. And we're only taking the sample as it is, and that will minimize tissue trauma, excessive bleeding, and also it takes very little time. In fact, if you look at my videos, it only took less than about 3 minutes all in all. And if we slicken the device further, we can even make it even easier and quicker and more efficient. So this is a case of a high speed, high technology and high efficiency, and it's directly relevant to the needs of the patient. And I think this is as far as we go for a minimally invasive option. Thank you very much.